Isn't it just beautiful? I mean, all those little dots in the sky that we call stars. You know, stargazing is probably the most common pastime in all of human history. I'm willing to bet that our ancestors were looking up at the same night sky I am now. They did so much more than just look at them. They studied the stars. They used the constellations to figure out the changing seasons. They used the North Star to guide them across the oceans. They even made myths and stories out of the dots because, you know, there was nothing else to do. But interestingly, it was only in the last 100 or so years that we found out what stars really are. This realization didn't happen in a day. We have to go back to the beginning. You see, since the 2nd century, the common belief was that everything in the universe, the stars, the sun, the planets, all revolved around us, the Earth. This idea, called geocentrism, stuck around for almost 1,500 years. That is, until in the 1500s, a man named Nicolaus Copernicus came up with a crazy idea. What if the sun was the center of it all? Today, we all know this to be true, but at the time, it was a very touchy subject. But it was the start of something big. Later on, Galileo improved his telescope and saw things in the sky that proved heliocentrism. Johannes Kepler took this one step further. He looked up at the planets and he noticed that they don't orbit in perfect circles, but in ellipses. He constructed his 3 simple laws of planetary motion, which describe how the sun and everything else move in space. Throw in Isaac Newton figuring out gravity later, and we suddenly have a working model of the solar system. This is already a huge step up from before, but the stars were still a mystery. They were just tiny dots of light in the sky. And before we could do any serious observations, we needed a proper map. Otherwise, the stars would be in a completely different position dependent on the time of day and the place you were on Earth. We borrowed our longitude and latitude system and expanded it across the sky. We call it the equatorial coordinate system. Equatorial because it's based on the Earth's equator, or the celestial equator. Every coordinate in this system has 2 things, right ascension and declination. Right ascension is how much to turn left and right along the equator from the point of view of the center of the Earth. And declination is how much to tilt up and down to find what you're looking for. Basically, a giant grid where we could find any location in the sky independent of where we were on Earth. Now that we had this system, we could build 2D maps of every star in the sky. But we still had the problem of figuring out how far away they were. That all changed with stellar parallax. Here's the idea. As the Earth goes around the sun, nearby stars seem to shift a little bit more compared to background stars. This is the same thing as if you were to put your thumb out and blink each eye. You can see your thumb moves slightly more compared to what's farther away. With that tiny shift and the distance of 2 viewpoints, we can determine how far away something is with basic math. In 1838, Friedrich Bessel did this first, on 61 Cygni. He discovered it was 10 light years away. 10 light years. That was farther than anything we'd measured up to that point, and suddenly the universe felt a lot bigger. But stellar parallax has a distance limit. The farther away something is, the smaller the change, and eventually we can't detect it, so we need something new. Enter Henrietta Swan Leavitt, one of the famous Harvard computers, a group of women doing groundbreaking star work in the early 1900s. She was studying these pulsing stars called Cepheid variables in the Magellanic Clouds. After years of observations, she noticed something incredible. They went from brighter to dimmer to brighter at a constant rate. She decided to plot these stars based on their brightness and how long it took for them to pulse. And she found a pattern. The more time in between brighter and dimmer states, the bigger the star really was. She could now figure out the exact brightness of any Cepheid variable in the night sky, and by comparing that to how we see it, she could figure out the exact distance. Her work was a game changer. If there was even one pulsing star in a star cluster or a distant galaxy, she could figure out the exact distances of everything around it. We started figuring out the distances of more and more stars, and seemingly overnight, our 2D map of the cosmos gained a dimension. But stars are so much more than just dots. At the same time, two other Harvard computers were doing equally interesting stuff. Annie Jump Cannon was classifying hundreds and thousands of stars into the OBAF-GKM classification system that we still use today. Here's how she did it. She pointed her telescope at the stars and put this in the middle, a prism. That broke up any light that was coming through into its components, a spectrum of colors, its stellar spectra. Annie Jump Cannon now had a unique fingerprint for every single star. And what she noticed was that every single one of them had these very defined lines with no color. These were the Balmer lines, the absorption spectrum of hydrogen atoms. She mapped each stellar spectra into categories. The categories were O, B, A, F, G, K, and M stars. For example, our sun is a G-type star. Now at the time, they didn't really know what these classifications were really saying about the stars. That's where Cecilia Payne comes in. In 1925, she took all of the spectral data on the stars and realized something. They were all made of the same thing, mostly hydrogen and helium. She realized that the classification wasn't the chemical difference between the stars, it was the temperature. Using this new discovery with the hundreds and thousands of stars that Annie Jump Cannon classified, she was able to determine the exact temperature, size, and color of every single star. Her PhD thesis is still widely regarded as the greatest in all of astronomy. And there you have it. Over the last couple hundred years, the greatest minds in history have come together to answer the world's oldest question. What really is up there in the sky? We went from knowing nothing at all and making up stories to having extremely detailed maps of all those little dots up there. Except we know they're more than just dots. They're giant balls of gas made of hydrogen and helium that are thousands of light years away. Next time you need something to do and it happens to be nighttime, look up at the sky and wonder.